Hi all, today we will discuss about virtual memory organization. So the virtual memory, the meaning of the virtual memory is that it's an imaginary memory. So the meaning of the word virtual is something like not real. So, so user feels that he has a memory whose size is as large as hard disk. So in general, when the programmer writes a program, this program will go and store in secondary memory, that is hard disk. From secondary memory it goes to main memory for execution. In general, it is 1 TB of memory. The size of the hard disk would be, and size of the main memory, that is RAM, capacity is of 8 GB. But so if the program want to be executed, it has to be in main memory, and it is not the total size of the program should be greater than, it should not be greater than 8 GB. If there is no technique called virtual memory, then it is required to have a constraint on the programmer that the size of the program cannot be greater than 8 GB. But this is not the case. The user can develop a program whose size is much bigger than the main memory. In fact, its size can be as large as the capacity of hard disk. And in this case, in the example, the size of the hard disk is 1 terabyte, 1 TB. Remember, 1 TB stands for 1024 GB. So 1 TB, TB stands for terabytes. 1 terabyte is equals to 1024 GB, that is 2 power 10. 1024 is the value for 2 power 10. So the virtual memory allows the programmer to develop a program whose size is as bigger than main memory, and whose size can be equal to the secondary memory. This is the goal of uh, virtual memory. In general, what happens if a program, when a user develops a program, that program will go and will be stored in secondary memory. And if that program want to be executed, then it has to be transferred from secondary memory to main memory. But there is a limitation on the size of the main memory. For example, its size is 8 GB. So, if the programmer or the developer develops a program whose size is greater than 8 GB, let's assume he developed a program of 10 GB size. So, in this case, it is not possible to store the 10 GB program in 8 GB RAM. So, if there is no technique called virtual memory organization, then it is not possible to execute any program whose size is bigger than or larger than main memory. And in general, we don't see such kind of restrictions while developing a program. The reason is the programmer is allowed to write or develop a program whose size is much bigger than main memory capacity. Then how it is possible to execute such program? And it is possible to execute such programs using the technique called virtual memory. So the virtual memory, the word virtual refers to an imaginary thing, imaginary memory, or the meaning of the virtual is not real, or you can say imaginary. So the general meaning of virtual memory is not real or an imaginary thing. So here virtual memory means the memory which is not in real, but it is an illusion, imaginary memory. It is some kind of, it provides some kind of imaginary memory to the programmer. So this technique is used by the operating system to manage for executing the programs whose size is bigger than main memory capacity. Before going to the virtual memory, let us discuss some important aspects of memory. All of you know that there are different kinds of memories exist in computers. For example, register. Register is the smallest memory element in computer, and this is very near to processor. Processor means a combination of CU, ALU. So register, whenever the processor requires some data, it immediately verifies whether the data is present in registers. So registers are smallest memory elements in the computer, and they can be accessed very fast by the processor. Next is cache memory or CPU cache. Remember, cache memory is a another fastest memory, and its capacity is bigger than registers. And the need for having cache memory is that it is used to store frequently using data or frequently using instructions. So CPU works on cache works on the principle of a special type of principle, that is, it is can only such type of data or instructions should be placed in cache which can be accessed very frequently in near future by the processor. So the best example is for loop. Remember, if I write a for loop in C programming, and the body of for loop can contain some set of instructions. So these set of instructions within the body of the for loop, they have to be executed iteratively for 0 to n minus 1 iterations. So it is very advantage to store such instructions in cache memory, because anyway you have to execute, you means the processor has to execute those bunch of instructions for n minus 1 iterations. Let us take the n value as 100. Then this group of instructions, body of the for loop, should be executed 0 to 99 iterations, that is 100 iterations. So it is an example for frequently accessing or frequently using instructions by the processor. So it is advantageous if these frequently used or frequently executed instructions in a special type of memory rather than main memory, because fetching instructions from main memory takes some longer time in terms of memory cycles. This leads to increasing execution time of the instructions. If such instructions are placed into special type of memory, then those can be executed in comparatively less amount of time. Here you may get a doubt, then why can't these frequently accessed or data or frequently executed instructions can be stored in register? Remember, registers are smallest memory elements which cannot hold all the instructions, large amount of data, or greater number of instructions. So it is required, it is very advantage to have a cache memory. So when a processor issues an address, then first OS will verify whether particular data or instruction is present on registers. If it is not available, then cache memory is verified to see that a particular data is present. If there is no matches for the address, then this address is compared with the main memory element's address. If even in this case, if the concerned address is not available, then this situation is called page fault. So what is the meaning of page, we will see. Remember, page fault is a situation where the desired address or the required address is not available in three memory elements. That is, the data is not available in registers and not available in cache memory and also not available in main memory. See, there is also exist another name for the main memory. It is called physical memory. Main memory is also known as physical memory. So here we have two new terms. One is page or page fault, then physical memory. We get some idea when we discuss virtual memory concept, may get clear idea what is page, what is a page, and why main memory is also known as physical memory. So after CPU cache, it is main memory, which is larger capacity than cache memory, and secondary memory is at level 4, whose size is bigger than main memory, and from secondary storage, even the larger size is server for internet. These days, data is not stored entirely on local system hard disk. The data, there are so many storage servers which provides some space by charging some amount. This is called a cloud storage. So in recent trends, there exist so many cloud servers which provides some storage to the prescribed users. When I say prescribed, they may charge some amount for providing the space. And of course, there are other cloud servers such as Google Drive, which provides storage for free of cost. So this is called memory hierarchy, which contains different memory elements within computer. Now let's see what is virtual memory called. So the virtual memory is a alternate set of memory addresses. That means They are they provide some imaginary addresses, set of memory addresses for the programmer. Programs use these virtual addresses rather than real or physical addresses to store instructions and data. So it is really important to understand the meaning of the word virtual address. Again, remember the meaning of virtual is not real. So the processor issues an address and that address is known as virtual address. Why? Because there is no such address or such address doesn't exist in main memory or physical memory. So the actual addresses or the set of addresses in main memory is called physical address. So virtual address means the set of addresses issued by the programmer is called virtual address, and the set of addresses issued by the programmer is called virtual address space. So virtual address space. Space means set of addresses. Next, like that, we have physical addresses or physical address space. So, the physical address space means the set of addresses in main memory or physical memory is known as physical address space. So let us understand one point, that virtual address space, that is set of addresses issued by the programmer, virtual address space is much bigger than physical address space. Why? Because the programmer has full freedom of having larger address space when compared with physical memory address space. So remember that always virtual address space is much bigger or much larger than physical address space. So when the program is actually executed, the virtual addresses are converted into real memory addresses. It is very important to understand this concept. Remember, virtual address is issued by the processor. Then let us assume this is my processor. Processor is combination of CU and ALU. When this processor issues an address, it is called virtual address. This virtual address has to be converted into physical address. Because ultimately the instruction has to be fetched from physical memory or main memory, and that address is called physical address. So the programmer may issue very large address, but it is which is called virtual address, but this address has to be converted into physical address because the instruction, after all, the instruction is being stored in physical memory. So it is very important to understand this conversion. Next, we will discuss some history about virtual memory. Remember, virtual memory was developed by uh, developed approximately in 1959, between 1959 and 1962 at University of Manchester for a special computer called Atlas computer, which is developed in 1962. In the year 1961, Burroughs released a special computer called B5000, and it is the first commercial computer with having virtual memory organization. So prior to this 1959, the programmer has a restriction that particular program size cannot be greater than RAM or physical memory capacity. So this is history about virtual memory. Next, we see the need for virtual memory. Before development of virtual memory technique, the programmers in the during 1940s and 1950s had to manage directly two level storage such as main memory or RAM and secondary memory in the form of hard disk or magnetic drums. So, using virtual memory, it is possible to enlarge the address space, that is the set of addresses a program can utilize. Virtual memory might contain twice as many addresses as main memory. So, first understand the goal of main memory or objective of main memory. When a computer is executing many programs, remember the computer or within that CPU or to minute level, a processor can execute more than one program, that is many programs at the same time. Virtual memory makes the computer to share the limited physical memory efficiently. So here constraint is that the size of the physical memory or main memory is limited. But using this limited main memory or physical memory, the processor should be able to execute many programs, more than one program. It is one objective. Next is eliminate a restriction that a computer works in memory which is small and be limited. Third objective is that when many programs are running at the same time, by distributing each suitable memory area to each program, virtual memory protects programs to interfere each other in each memory area. So when the process understand this last point, when processor executes more than one program, then it may be quite possible that one program may try to access other program memory. So this virtual memory provides protection for not accessing other programs data. Let us see how this technique called virtual memory works. To facilitate copying virtual memory into real memory, the operating system divides virtual memory into pages. Each of the page contains a fixed number of addresses. Remember, physical memory or main memory is also divided into fixed size pages. This is called page 1, page 2, page 3, and page 4. If let's assume the size of the main memory is 8 GB, then the size of the page should be, each page should be 2 GB, because we are dividing 8 GB physical memory into 4 pages. So the size of each page is fixed to 2 GB. Each page is stored on a disk until it is needed. That means we can divide secondary memory also into some pages, which are called segmentation. When the page is needed, the operating system copies particular page from the disk to main memory or physical memory. Why? Because if a particular instruction or group of instructions or the whole program wants to get execute, then the particular program should be present in main memory. So all the program which is developed developed by the programmer is divided into a special unit called processes, and also the secondary memory is divided into fixed size pages. Similarly, the main memory is also divided into fixed size pages. Initially, all the pages or all the processes, remember, process means a program is divided into different processes, and remember, a page can accommodate at least one process, or it can accommodate more than one process. Initially, when the user or programmer develops a program, that program is divided into processes, and those processes are stored in pages in secondary memory. When the page is needed, the operating system copies it from the disk to main memory, translating the virtual address into real addresses.